Hello everyone, I am Sarayu. I am currently pursuing my BTech first year in Institute of Aeronautical Engineering in AML branch. Today my topic is about degree of sequence analysis of social networks recent advance. Let me give introduction about what is degree sequence. List of vertices degrees in graph. Why degree sequence matters in social network. Capture basic connectivity properties helps in the modeling, comparing networks, null modulus, etc. In simple and undirected network, G is equal to V comma E. Each node V belongs to V has a degree. D of V is equal to the number of edges instant on V. The degree of sequence of the network is the list of the all node degrees, typically sorted in non-increasing order. D1 greater than or equal to D2 greater than so on greater than or equal to Dn, where n is equals to module V. In social networks, the degree of sequence captures how many ties each individual has. For example, how many friends, contacts, co-authors, etc. It is one of most fundamental structural descriptor of networking because it captures in connectivity. Some nodes may be highly connected hubs, other may sparely connected. Classical background, simple properties, degree distribution, power law, Poisson, etc. Configuration models, preserving degree sequence used as null models. Associative degree correlations, rich club coefficient. Why it is important in social network? Heterogeneity of connectivity. Social networks often have heavy tail degree distributions. That is, many nodes with few ties, a few nodes with many ties. This affects diffusion, influence, relations, etc. The degree of sequence is the raw data behind that heterogeneity. Null model, baseline, and comparison. Many analysts ask, is the network structure simply a consequence of degree of the sequence, or is there additional structure? On the top of that, a common method generates a configuration model random graph that preserves the empirical degree sequence but randomizes everything else. Then compare real network metrics to baseline. Challenges and limitation of traditional degree sequential analysis. Degree sequence alone does not capture clustering community structure or higher order structure. Two networks can have the same degree sequence but behave very differently in dynamics, diffusion, etc. Static versus dynamic networks. Time evolution, temporal degree changes. Recent advance, extended sequence measures and neighborhood sequence. Neighborhood degree sequence for each node record the degree of its neighbor and gives extra structure. Measure direct neighborhood similarity, heterogenetic organization, hierarchical complexity. Finding many social, biological, tech networks show greater similarity and organization than expected, giving their degree distribution. Dynamics of process. Because of the nodes of different degrees have different roles, may act as a hubs in the diffusion, bridges in connectivity, or have different relations. The degree sequences shape how to information, influence, and other dynamics proceed on the network. Degree of sequence across subgraphs and higher order structure. Recent algorithms to generate networks that preserve degree, sequence, and control other features like clustering or sentence subgraph. Example UDA and CMM methods. OUP academic. How different placements of subgraphs, triangles, etc. affect global metrics even if the degree sequence plus global clustering keep it same. OUP academic. Key aspects of degree sequence analysis. Here are some of the main ideas and concepts that researchers studies around degree sequence. Graphicality and reusability. Give a sequence of non-negative integer d1 to so on dn. Under what condition does there exist a simple graph with exactly the degree sequence? This is a classic graph realization problem. The fame, then there is a Havel-Hakim algorithm for constructing a graph or verifying by iterative peeling of the largest degree node. In social networking setting, if you have the degree sequence of observed ties, you might ask, does the data admit a simple graph? If you are knowing working with generative model, you might constrain it to match a give degree sequence. Degree distribution versus full sequence. Often people speak of degree distribution, the empirical or theoretical distribution of degrees is P of k is equals to fraction nodes of a degree. But the full degree sequence carries more information, including node specific identity, some analysis condition on the sequence rather than the just distribution. Configuration model degree preserving random graph. When you preserve the degree sequence exactly but randomize the rest of work for the net, you may obtain a null model. This allows you ask two questions. Degree encoding in learning and graphing model. Using degree as a features in graph neural networks or other ML methods. Example, using degree encoding in sequential recommendation with GNNS plus transfer encoders MDPL temporarily or dynamic degree sequence analysis. How degree sequence evolve over time in the dynamic social networks? Measure that consider temporal snapshot, dynamic weights, and etc. Temporal degrees or closeness, etc. Degree sequence and network process. Because high degree nodes plays a special role, the shape of the degree influence. Centrality ranking degree is the centrality is directly the degree but may other centrality correlate with the degrees. Influence, spread, diffusion, extension, degree sequence concept. Beyond just listening degree, recent work takes into account neighborhood degree sequence for each node. Look at the multi-set ordered list of degree of its neighbor. This is at the second order structural layer, for example, on neighborhood degree sequence of complex networks. By degree sequence in the indirected biparent networks nodes have in the degree and out degree and one studies that joint sequence. Example, affiliation networks with an increasing degree sequence. Higher order structural constraints gives degree sequences for instant networks with a given degree sequence but it with adjustable clustering or superposition analysis. With the prescribed degree sequence and subgraph, higher order structure matters. Recent and advanced trends. Here are the some most recent development since from last 5 years. In degree sequence analyzing of social and complex network, especially where there is a twist behind the classical degree sequence, neighborhood degree sequence or second order degree sequence. On the neighborhood degree sequence of complex networks, indicators such as neighborhood similarity and organization or similar or the neighbor degree sequence of nodes with the same degree. Exam overall 200 real world networks, social biological technology. Key site. Key insight. Real networks had higher organizational similarity structure than the random counterparts with the same degree distribution. Degree preserving growth. Dynamic modeling. Some more recent work speaks about growth model where is a degree sequence held fixed. While evolving the other structure, this is useful for social networking, evolving over the time, where degree might remain roughly stable but its links, who is connected to whom, changes. Graph generation with given degree sequences plus higher order structure. Generation and analysis of network with the prescribed degree sequence and subgraph family higher order structure matters shows that even when you fix the degree of sequence and global clustering networks can differently market in the higher order structure subgraph distribution of subgraph and those difference matters. The degree of sequence necessary but not a sufficient structural descriptor if you can share about the details of diffusion and in social networks. Implementations of network dynamics. Epidemics, diffusion, information, spread, behavior depends not only on the degree of distribution but how degree correlates with the clustering community structure. Difference in locating hubs or influential nodes when the neighborhood structure subgraph, etc. Open problems or future direction. Better null models that preserve more structures but are still traceable. Understanding how degree based on the futures affecting learning methods, fairness and interability. More work on the dynamic streaming networks, how to handling changing the degree sequence in the real time. Scalability for a huge social network. Interplay of the degree sequence with the node attributes, multiplex and multiplier networks. Case studies and example. Use one or two real social networks. Show the degree sequence, neighborhood sequence, what new sites are gained. Perhaps compare two networks with the same degree sequence but different subgroups distributes show how metric differs. Key sites. Degree of sequence is fundamental but not everything. Preserving a degree of sequence in the null models or generating is the strong constraint. Hub matters. Nodes with a large degree often dominates diffusion centrality reigns. Inference estimation matters when the network data is sampled or partially typical in the social networking or reconstructing the degree of sequence is the key step of reliables. Conclusion. Recap. Degree sequence remains fundamental but recent advances go beyond sequence higher order structure dynamic analyzing learning models. The importance of rich futures of for modeling, prediction, understanding social networks. Recent advice have depended the analyzing by looking at neighborhood degree and dynamic degree sequence in evolving networks and generating models that preserve degree of sequence while varying other structure. For anyone working in social network analysis, carefully examining the degree of sequence and what it does and does it explain it is a key step. The important rich future of modeling and prediction understanding social networks. Thank you.